Hey, what is up everyone? In today's video, we're going to take a look at making this beautiful looking bubble shader for your Apple Vision Pro apps. We are going to first look into making the shader graph for the material of the bubble. Then we are going to expose some parameters of the shader so we can create the bubble popping effect. Finally, we are going to write some code so that we can create and animate this bubble popping effect. My name is Sarang Borude. I know a thing or two about making beautiful looking spatial computing apps. So without further ado, let's get into it. Okay, so we'll start with a very new vanilla VisionOS app. We'll call it Bubbles and let's click next, create the project. We are not going to do much in Xcode right now, so we are just going to go into RealityKit content and open the project in Reality Composer Pro. So the first thing we are going to do is going to start by creating a new scene in Reality Composer Pro. Let's call this scene the bubble scene. Okay, let's open bubble scene, make sure it's open. I'll close any other scene to avoid confusion. Right, so our scene is open, it has the root transform in it. I'm going to go to this top right corner here. In the content library, I'm going to add a sphere. I'll select the sphere here. I'll put its X position to 0, Y maybe a little bit high. This is in meters, so like 0.7 meters up in the air. And then I'll put it in front of us and it will be minus 0.5 to start. So to focus on it, what I can do is I can select the object and hit Command F, and Command and F essentially focuses that thing, brings it in the center. You can see that this sphere already has a material, default material. If you click on it, it's here in the binding property. So what we are going to do is we are going to delete this material. And we are going to hit this plus button in the bottom of the hierarchy pane on the left. We'll go to material and custom. Let's rename this material to be the bubble material. Okay, and let's try and assign this to the spheres. If I select the material and go to the shader graph tab here, you can see that it's pretty simple shader graph. So you can see that the shader, the material is associated with the sphere right now. If I make any color changes, they're very apparent here. So to make a bubble shader, what we need to do is we need to make it super glossy. So we can do that by changing the roughness to 0. And you can see it's reflecting the environment right now. It's very shiny and bubbles are very transparent, so let's change its opacity to something very low like 0.15. Experiment with this value. So now we have a basic bubble. You can just directly use this thing. It's not super exciting because a bubble has this interesting characteristic called iridescence. With iridescence, you can see these like different color patterns on the bubble. To do that, what I'm going to do is just make some room over here. We'll start with a noise 3D node. Okay. Noise 3D has like 3 inputs. The amplitude is essentially the intensity of the noise at a point. Pivot is kind of like what is the basic starting point for the noise. So it starts from 0 and goes up. Position is basically, if you imagine noise as like a 3D, it's kind of like a cloud in a 3D space. Then if you point to a position in that cloud, what is the value of the noise at that particular point is what we'll get. The position we need is basically the position on the surface at a point on the surface of the bubble. That's what we are looking for. So we are not at all going to change the amplitude and the pivot in this particular shader. We'll just play with the position. So let's create the position node. right? So we want a point on the surface. We will change the space of the position node to world, because it's kind of nice if the bubble kind of creates different patterns when it's at like different positions in 3D space. And you can do that by selecting the position node. In the inspector you have space, and change that from object to world. Let's create a color node and multiply the output of the noise with the color node, and simply apply it to the emissive color for now. And let's change the color to bright red, right? And you can see nothing is happening. Let's try connecting the position. Still nothing is happening. Well, something is happening, we are just not seeing it. It's probably because like the noise, it's scaled too low. So let's increase the scale of the noise by multiplying the position. So I'll take this node, I'll create another float. I'll call this float maybe noise scale. Let's see, maybe bring this in center. Okay, so this is what I did. I created a noise scale, and now I am multiplying it to the position. And now when we change this value to, let's say, 30, so now you can see something here. You can see there is a pattern that's happening on here. So that just gives us one color. So this is a nice input for our shader. So let's promote this to uniform input. What promoting does, it creates almost like when you select the material, it becomes like the uniform input. So you can change that in code. So we'll create multiple copies of this pattern and hopefully see some like iridescent effect. Like, let's just copy this whole thing. Right? And then if we add these two outputs, maybe change the color here. Let's make it green. And then if we try to add the output, here you can see like the color is yellow. It's kind of mix of green and red colors over here. The reason is because like the noise being generated is the exact same pattern, so it's getting like overlaid on top of each other. We are going to add an offset in the position. Maybe not this one. I'll just play around with the original one. So let's take this, we'll do add. Okay, add, and we'll create another vector3 input. We'll attach it here. Let's call it noise offset. First, what we'll do is let's promote it to input, because this is something that we want to play around with later. So I'll probably set its off value to, let's do 1 1 1. Okay, not too much. It's just like I'm adding a random value. It doesn't have to be precisely 1 1 1. You can select anything you want. But once you've added it, and when now that you kind of add that, now you can see like the pattern is kind of interesting, right? You have added an offset to the red color noise, and it separates from the green color noise, and then wherever there is an overlap you see this yellow pattern. So let's just like delete this thing. Okay, so I think what we are getting at is we want to create 3 copies of these, essentially for like 3 different color shades. Let's just do that. Let's see what happens, right? So if I create another copy and another copy, right? So let's say this one is green, which we originally had. make this one blue. Sweet. So, and we simply add the output. And then we add it to the emissive color. Let's move it a little bit so you can see what's going on here. You can see that the color is now overlapping because of course we have not changed our offset. So let's change our offset values to, like, let's say for 1 we'll do 2 2 2 3 3 3. All right, so you can see like now we have the iridescent pattern that we are kind of looking for. And I think it's a good idea to like even expose this color to input, because we can control it from the material itself. But what we have right now is quite the spaghetti of the shader graph, right? Like it's starting to get complicated, and it's a little bit hard to read. But I think what we can do is we can clean it up a little bit. But like before we do the cleanup, I also want to see like the pattern on the bubble doesn't stay constant like what it is doing right now. I think the pattern on the bubble really is animating all the time. It's kind of moving. And our best friend to do that right now is the time node. So what I'm going to do is I'm going to create a time node. I'll create the time node. I like to do this where I simply multiply the time node with some kind of like float. The reason I do it is then I have control over the speed of the animation. So I'll call it animation speed. Okay. And if we take this thing, if we add it with the noise offset, this is what we'll get. So, all right, so we are adding these two values and we'll simply replace, and the animation speed is 0. But what if we make it something subtle like 0.1? So you can see now the red pattern is actually animating a lot, right? How about, let's make it really subtle. So like 0.05. Too slow, so maybe 0.01. This is something I like. I think this is good. Essentially, you'll see like we'll have to copy these all over again, and then it will further make the whole shader very complex, right? So how about we make our shader simple, right? So what I'm going to do now is show you how to create a subgraph or a node graph so we can simplify our shader. So I'm going to delete everything that we just did. All right, and this is kind of like the graph that we want to be repeating, right? So you have, let's call it the noise color. We have noise color, noise scale, we have the noise offset, and we have the animation speed. Let's just like promote that to be a uniform input as well so we can control it externally. So what I'm going to do now, I'm going to select all these nodes, right? And I am going to right click on it, and I am going to, let's see, it doesn't come on like if you right click on the promoted input nodes, but if you click on pretty much any sort of purple looking nodes, then you get this option called compose node graph. So what compose node graph gives us is this. So we created a node graph, we'll call it generate noise, generate color noise. So in this particular case, we have this cleaner looking shader now that does essentially the same thing. For fun's sake, I'll just delete these two, like the noise offset and these, and we'll just delete. So we'll just have two. Okay, you can see that the names here are kind of weird. So if you double click the shader, this node graph, you can go in here and you can rename these things. So let me rename this to animation speed. Let me call this what is this called, noise offset. This thing was our noise color, and then I think this thing is like noise scale. So we create a subgraph. This is what the subgraph kind of looks like. You can be more hygienic and like do this, so it's kind of very easy to read. And then if you go back, you can see like now it has the right names. All right, so it essentially does what we were doing. So let's just move things a bit so you can see things clearly. Yeah. So let's just change the color here to red, maybe a little bit purple. Then I'll essentially duplicate this thing, apply the same animation speed and noise scale to it. And what I'll go is I'll change the noise offset to 111, select and change the color to something kind of like greenish yellow, somewhere in between. Okay, and then I'll do another copy of it. Same thing, so I'll connect the animation speed and noise scale. So we have now 3 copies of this, and now we'll simply add the output. Oh, and I forgot to change the color to maybe something like pastel blue. Yeah, maybe that's good. So what we are going to do is simply add the outputs to our shader, and voila, we have something really interesting looking. Let's change the amplitude to the offset to 222. You can play around with these values, but now our iridescent effect is looking very interesting. It's animating kind of randomly. So this is kind of what we are shooting for. So that kind of gives us like the colored appearance of the shader. So this is essentially a nice looking bubble that we can use. So now what we are going to do is we are going to take a look into like how we can create the bubble popping effect, and we are going to use noise for that as well. I'll start with creating a noise node. So let's create noise 3D again. In this case, we'll still use the position node. And we'll create a scaling factor so that our noise is properly scaled. So we have done this before. So you simply do multiply again, and then we'll create a float. Let's call it pop whole scale. I'm changing the value of this to be 30. Should we do 30? Let's do something high. Let's do 50 as we go. But like, you take this in, you simply multiply that with the position, change nothing else, and if we kind of apply this to the ambient occlusion, so you can see like the value of it as this changes, you can see that there are holes being created in this mesh. So it's kind of like interesting to see this effect, but the popping effect needs to not be soft. So what we are going to do is we are using a step node, So if we use a step node and we are simply adding the output here, you can see that adding the step node gives us a very sharp edge to our noise, and this is what we need for the pop effect. Now we want the pop effect to sort of go from like 0 to 1. So let's just create a float and see what happens. So if I create a float variable, just a random float variable, and if I simply add the output of the noise and this float, let's see the effect we get. So now let's try to manipulate this, right? So if I take it to, let's say 1, it's fully opaque. If I slowly bring it down, you see like this is the popping effect, right? That's exactly what we want. So I'm going to create this property that we can manipulate in code. We'll call it pop. Then we'll simply we want it to go from 0 to 1, right? So we can use the remap node. So our input is going to go from 0 to 1. 1 is fully popped, 0 is not popped at all, and then our output, maybe we can go from -1 to 1, and let's see the effect now. Alright, so you can see that this is doing something properly with the ambient occlusion part of the node. We need to do something with the opacity as well. We cannot just simply connect this to opacity because it kind of brightens up the whole balloon, the bubble. What is happening here is that we want to control opacity slightly differently, so that the brightness of the bubble doesn't change, or the opaqueness of it doesn't change, that it kind of maintains a certain level of transparency. So what we are going to do is we are going to insert a remap node here, and then we are going to, the input is going to go from 0 to 1, and the output we want to go from 0 to 0.15, because the maximum opacity we want for our bubble is 0.15. You can totally tweak this later, but now if you look at our effect, it kind of goes like this. Alright, so that's the output value. So what we can do here is, like, I want it to be inverted. So like when the pop value is 0, the bubble is fully intact. And then when the pop value goes to 1, let's see this. Okay, so this is the perfect thing that essentially completes our bubble shader. So let me move this a bit. We'll also promote this floating value to a uniform input so we can change it in code. So here's what we want to do next. We want to essentially animate the pop value that we have exposed, the pop property that we have exposed for the material. We want to animate it when the user does a spatial tap gesture so that we can create the bubble popping effect. So that's exactly what we are going to do next. We are not completely done yet in Reality Composer Pro. There are a few things we need to do so that we can make this bubble interactive. So we just renamed our bubble. We're going to select our bubble, and then we are going to add a component, and we are going to add a collision component, and then also add, when we add the collision component, let's change its shape to sphere so it kind of perfectly fits. So shape in collision needs to be changed to sphere. Okay, the default is box. That's not the right one for a sphere, isn't it? Then we'll add a input target component. The input, so what this does is basically it detects when any kind of like interaction is being done on the bubble, and then essentially uses that to register the input on the bubble entity. So we have it, our scene is kind of ready, but let's create some copies here. we are really not randomizing the bubbles yet. I think it's better to do that in code, apply some physics, do that stuff. For now, this is just good enough for us to play around with. So let's save the scene, and now let's just jump into Xcode. Alright, so in Xcode, what we are going to do is we are going to our immersive view, which you see here. So this is created by default. I didn't write any of this code. This was in the default project. I'll change the scene name from immersive to bubble scene. Just to reiterate, when the new project gets created, it has this scene by default called immersive.usda. We created a separate scene called bubble scene.usda. So now we need to tell Xcode, like, hey, I want to open the bubble scene. I just replace immersive with bubble scene, and I'm really hoping that this works. So if you go to show immersive space, you can see that our bubbles are being created, right? So they're kind of here, created right in front of us, and they look quite nice, right, in the environment. And you can see the animation is happening on them. All right, next, let's add some interactivity. So we are here at the reality view. What we can say is, I want to add a gesture. Gesture, we want to detect the spatial tab gesture. Spatial tab gesture, we can start with that. And we can do targeted to entity. So now here it's asking for a specific entity, or there is also another one where you can pass it a predicate to find a specific kind of entity. So it is looking for some query predicate. So we need to make that query predicate. And the way we make it is essentially, we'll say here, we'll create a state variable. So add state. We'll do var predicate. Predicate is to query predicate. We want to query predicate an entity has. So here in this query predicate, we are basically creating a predicate that's specifically looking for anything that has a model component. Model component is essentially where the mesh and the material gets applied to. So in that case, it's going to be our bubble. So I'll just do predicate here, and then you want to detect the event here, right? So in this particular case, what I'm going to do is I'm going to hit on ended. Okay, and then it gives me a closure. All right, so we are in this closure right now. When a tab gesture happens on anything that has an input target component, so what the tab gesture will give us, it will provide us with this value, and from that value we can get our entity that has been tapped on. So we can do value dot entity. We can do now we want to get the material of the entity. So we want to do entity dot components model component. Materials first as shader graph material. So I want to just quickly show it. That's why I'm kind of like unsafely opening it, the optional, but ideally you should do something like guardlet and see if the material is present. Then what we are going to do is we are simply going to do some math to figure out how to animate the shader. So at this point we have the material, right? And we simply want to animate the material's pop property to go from 0 to 1. And The way we can do that right now is using a timer. So the way this is going to work is pretty straightforward. We have the timer that kind of goes from like 0 to a particular amount of duration, and in that duration what we are going to do is we are going to animate the pop value to go from 0 to 1, and that's how we kind of create the pop effect. So to do this, what we are going to do is we'll do let frame rate so we are doing 1/60, which is 60 frames per second. Then we do the duration, also a time interval, and that is going to be 0.25. So we want the bubble to pop in 0.25 seconds. Let target value, we want it to be float, and let total frames will be duration over frame rate. So you'll be saying, why are you being so crazy and paranoid? Why are you adding Swift is type safe? Why are you doing this? Essentially because we are doing some conversions here, so it's just better to tell that what is a time interval and what is a float. All right, moving forward, we'll set our current frame to be at 0, and then we kind of need a variable to store our pop value. That also is a float and is beginning at 0. Okay, so now comes the fun part. What we are going to do now is create a timer. So we want the timer. So to create the timer, I'll go on the top and I'll create a timer. Let's say state private var timer. All right, so now what we are going to do here is we'll do timer dot invalidate. So if there is a previous timer running, just invalidate that. Now we should create our timer and we'll save it into our timer variable that we have created. So timer is equal to timer dot schedule timer, and we'll use the first one here with time interval, repeats, and block. So the idea behind the timer is like the timer repeats every frame, so pretty much 60 times a second, and every time it repeats we want to progress the pop value. So we select the time interval to be the frame rate, repeats to true because we want to keep repeating, and then we have the block. So we have timer and in the block, now this will be the repeating kind of like update block. What we are going to do is we are advancing the current frame by 1. We'll create a progress variable, and we're calculating the progress by where the current frame is and the total amount of frames. So essentially when the current frame matches the total frame, that means we are basically saying the progress is 100%. Then what we are doing is we'll take the pop value and we'll also update it, increase it, right? So we'll do it progress times the target value. So our target value is 1. As the progress kind of goes, the pop value will kind of go from 0 to 1. And then finally it comes the time to assign our pop value. So what we are going to do is we are essentially going to set the parameter, and you have to enclose it into a do block, and essentially do try material.set set parameter. Set parameter name is going to be, our name was pop, and the value was a floating point number, and it will be pop value. All right, so this is what we are going to do, and this kind of threw me off a little. So like when you set the materials value, now what you have to do is you have to assign it back to the entities model component. So we'll do entity components, we'll do model component.self, materials, and this is an array, so we'll basically reassign the material with the updated pop value. We will catch any errors, and what we are going to do now, if the current frame is greater than or equals to total frames, we are essentially invalidating the timer so it doesn't keep on going. And then we also want to delete the bubble, right? So what we are going to do, simply entity.remove from parent. So this is essentially what we are doing to make the bubble pop. So I'll reiterate it real quick so that you can fast forward and just watch this. So we created a spatial tap gesture. We create a spatial tap gesture here. We are essentially saying that I want the spatial tap gesture to detect a particular entity. The entity is defined by this predicate. If we go back up, the predicate is basically like any entity that has a model component on it. So in this case, it's just going to be our bubbles. Okay, when the spatial tap gesture is ended, what we want to do is like find the entity that it was targeted to, which is stored in like the value of the spatial tap gesture. And then what we can do is like we are essentially finding our material. We are kind of casting it as shader graph material because that's what we created. Then we are doing some mathematics to calculate like how to update the pop variable as the timer progresses. So here in this particular case, what we are doing is we are calculating the frame rate. So we are using a frame rate of 60 frames per second. We are animating for the duration of 0.25 seconds, and then we want to go to the target value of 1. The total number of frames is going to be duration by frame rate, and we're basically setting up the variables to for the timer to work. In the timer essentially fires every frame. We are kind of updating the frame and the pop value slowly, and then finally we kind of animate the parameter here. So this is the most important piece of code. Essentially material.set parameter is setting the value, pop value, and here we have basically updating the incremented pop value. One thing to note, this is very important, is please assign back the material to the model component again once you have modified it, otherwise the changes don't show up. Very important note. So that essentially completes it. So now when I run this project and I hit show immersive space, let's just go back a little bit, and when I click on it, our bubbles are popping. All right, so thank you so much for making it to the end of this video. I know this was a long one. We covered a lot of things. We covered how to create subgraphs, how we add spatial tab gestures, add interactivity, how to use timer to manipulate. There are things that can be fixed, like you can still work on improving how the iridescent effect on the shader looks. There are also things you can do where like I tried to figure out like what is the best way to animate the value, but currently that's not something exposed. We have to hack it with a timer. If you know a better way to animate the material, please let me know in the comments below. This will be huge help. But I hope you had some fun. There is something more that's coming in the next video. What I'm going to do is I'm going to instantiate these bubbles at random spots and also going to animate it and just kind of make them float in the space, so you can create this nice floating bubbles being generated and like you can then pop them. So we are going to do something like that in the next video. So please like, subscribe, and please stay tuned for the next video. It's going to be a short one, but we're going to learn how to like dynamically move the bubbles in the space using physics. So it's going to be a little bit interesting. Please, thank you for watching. Thank you for making it to the end. I hope to see you in the next one. Ciao.